analysis application. Hello, Swapnil.
Yes, good morning, Ajay.
Yeah, you can hear me, right?
Yes.
Yeah.
You are able to hear me?
Right. Swapnil, you can start the session. I'm handing
Yes.
over to you.
Okay. Thank you. Thank you very much.
Yeah.
So good morning, everybody. Good morning and welcome to EDS Technologies webinar for empowering designers to make quick product decision using integrated analysis applications. Here we'll be concentrating on the CATIA analysis capabilities which are inbuilt in the software, so which will definitely help the designers to design their parts in very less time and accurately. So we'll proceed. So this will be the agenda for our today's session. Initially we'll see brief about our portfolio from EDS Technologies, then brief about the finite element method analysis, which is the foundation of any CA tool. After that, we'll see the CATIA capabilities for the analysis, which will definitely help us to the designers. So integrated solution of the CATIA for the analysis. Then few of the industry use cases, some of the customer references, and beyond CATIA analysis, what are the capabilities that we can extend. So those things also we'll see. So EDS Technologies, our head office is located at Bangalore. We are the largest PLM solutions provider across the India. Last 22 years we are serving this CAD CAM CAE PLM industry. We have pan India presence across say 13 locations, more than 200 associates, and the strongest part for EDS Technologies is we have more than 1500 customers, right from OEM to tier 1, tier 2 suppliers, as well as few of the small scale industries as well. See, this is the key differentiator from the competition. EDS Technologies differentiates its domain expertise, consultative approach, and understanding of customer pains and their requirements to drive successful implementation with world-class training and technical support. Because of this only, we are the leaders since last 2 decades. EDST strongly believe in the quality approach. When we give the quality support, technical expertise to the customers so that their profitability increases, so customer success is our success. EDS Technologies is the world-class training facility provider. We are certified education partner to the Dassault system. We are the one of the oldest partner to DS for the certified education. Along with that, we also have the Autodesk ATC, that is Authorized Training Center, to improve the skill sets of the people. This particular slide will help us to understand the different portfolios of EDS Technologies. See, we have different verticals like engineering solutions, then enterprise solutions also we provide, along with that engineering services. In the engineering solutions, we have PLM domain, mining domain, and visual simulations. As far as this PLM domain is concerned, and for the today's webinar, we'll be concentrating on CATIA, especially the CATIA analysis capabilities. CATIA is the most widely used software for the design across the world, and it is used by different domains as well. Along with that, the analysis capabilities are also provided with SIMULIA brand, where Abaqus, iSight, Tosca, the different solutions industry uses strongly for their higher-end analysis capabilities. Besides that, we have Delmia, Innovia, 3D GeoWare, then the Exilid, Ramsys, QChecker. These all are there with our PLM portfolio. Along with that, we also support for mining as well as visual simulation products. Then SAP products and also the engineering services, CAD CAM, CAE implementation, SAP implementation, and Innova implementation. These are the different industry verticals served. Almost all industry verticals, right from automotive, electronics, aerospace, tooling, shipbuilding, packaging, fashion, sports. Almost all industry verticals are served by our different types of products which we have in our portfolio. These are the strategic partners, principal partners to AEDS Technologies, Dassault System, SAP, Human Solutions, and the others. Now we'll see the little basics about the finite element analysis, because for any of the analysis CAE tool, finite element method is the base. It is the foundation block for any analysis software, where we have a model built in the CAD. Then what we have to do is we have to discretize the model. We have to divide the model into finite elements. Small elements are created. The discretization can be 1D, 2D, or 3D elements. For this case, these are the 3D elements. After this discretization, that is the meshing, we have to provide the boundary conditions, the restraints. Then what are the loadings are applied onto the part? Maybe it's a distributed force, pressure, okay, inertia forces, so that can be applied, and this model, finite element model, is given for the solution. So the solution will get it. For its visualization, post-processing tools are required to visualize the and understand the solution given by the solver. With the help of that, we'll be able to understand where the stresses are more, where the deflection is more, and accordingly, if required, we can do the mesh refinement as well, and to get at the proper solution at last. The finite element method basically has these 3 steps: pre-processing, computation, and the post-processing. Initially, when the pre-processing is done and it is solved and the results are viewed through this post-processing, if some mesh refinements or some optimization is to be required, we'll do it, and then final solution will be created with the help of reports. The HTML reports can be created very easily. So what happens exactly in pre-processing? So this is pictorially shown here. we have a model, 3D model, actual part. To it, we'll apply the materials which will give it to properties like Poisson's ratio, modulus of elasticity, and then it will be discretized. The meshing will be done. Inside the CATIA, the meshing is automatic. Along with that, at certain critical areas, we can do the local meshing as well, and we can modify the properties to get the better results. Then that model will be applied, finite element model, will the loads. By applying the loads, then we'll apply the restraints, whatever the boundary conditions and restraints are there. So they will be applied, and this model is given for solving. That is the computation step. So the software will solve it. It will give some numerical results. To understand these results, we'll use post-processing techniques to get the deflections and the stresses graph. With the help of this color graph, we'll be able to understand what are the, where the stresses and the deflections are more, so we can identify that. As previously said, at critical areas we can do the mesh refinements, and finally the reports will be generated with the help of HTML format. So it will very user friendly, and in very less time the designers can understand their design and get the solution for it. So that was the basics related to FEM. What exactly is available in CATIA and how it is done, that we will see. This is a typical graph, how the industry has evolved since this introduction of computers, because initially when the computers were not there, the finite element method was very cumbersome to do those calculations and other things. So when as the computers arrived, then initially some 2D softwares, then 3D softwares came, then we will be able to make assemblies, its digital mock-ups, we will be able to do the simulations, kinematics. Then came this product lifecycle management, where with the help of it, different people from different locations, they can concurrently work, that is collaborative engineering they can have. And nowadays it's the realistic simulation and the lifelike experience. Actually we can feel the analysis, and it's very easy to do this analysis with the help of this current tools available. This CATIA analysis comes under SIMULIA. SIMULIA is nothing but for simulation. Along with that, for higher capabilities, we have other products which will be very clear through this technology sophistication versus different rules. So here the CATIA analysis comes, where the designers are using CATIA. These analysis capabilities can be integrated inbuilt in the CATIA, the same environment. Along with that, for advanced simulation options, we have Abaqus for CATIA V5. For nonlinear higher-end analysis, Abaqus is the software in this SIMULIA brand that can be used for the analysis. So for today's webinar, we'll be concentrating on this CATIA analysis capabilities. This is the traditional product development process. So the issue for this is the time taken for the complete design and the testing of the design is very high. Initially, the designers will make their concept design, because that design will be done in some another solution and it will be analyzed with a different software, different solution. So analysis validation. Then after doing analysis, there might be some modification. So the iterations need to be done. So design iteration 1. Once again, this need to be tested. Say analysis validation. So n times this design iteration may be there, and finally we'll get the solution. So it increases this time. So there will be no link between the geometry and the analysis. Associativity between the geometry is lost. While with the help of CATIA analysis, which is the integrated analysis inside the CATIA, same GUI, same environment. So whatever the concept design is made, so at the same time we can launch the CATIA analysis, that is GPA.js workbenches. We can do the analysis, we can understand the results from it, where the stresses are coming more, the deflection is more. Inside the same environment, the design iteration will be done. At the same time, it will be tested once again, and this reduces the development span very drastically, and with the very less errors as well, because there are no data translation errors in this particular case. As we are discussing, this is integrated with the CATIA design environment. Inside the same environment, we'll be doing it. Whatever the design or the models are created on the same, the analysis capabilities, that is pre-processing, solving and post-processing, so they will be applied, and after modifications this updation will be automatic. So the analysis model will be updated automatically. No need to once again do the same things again and again. Along with that, knowledge based architecture, we can create the templates. There can be some parameters, there can be some design tables, and if we want to change the configuration of initial design, the parameters will be changed, and the same analysis will be performed very easily. So here we have a original model built in the CATIA. It will be analyzed, and based on the results, some modifications are done in that model. So it is structure analyzed and optimized for the weight, and finally within very less time we can get the final design. Importance of identifying the mistakes and error at initial stages. When we identify these mistakes initially in the initial design, so it helps us a lot, because it has been studied that the cost of fixing mistakes increases by a factor of 10 as you advances from one development step to the next. So as these errors and mistakes identified at very later stages, this will increase the time as well as the cost for that particular product development. The key important thing as far as this CATIA analysis is concerned, as we have discussed, that is integrated into the CATIA. and it is very user friendly. In the same interface, we can apply the different features for analysis in the same environment. And this analysis specifications are geometry based. If we do the changes in the geometry, then we come to the CATIA Analysis workbench. We can just update it, and the same for the analysis, the results are updated, and we'll get the results for modified geometry with a very less time. As we have discussed, this CATIA will have this automatic mesh generation, but many times at some critical areas we require the mesh refinement. So this, with the help of adaptivity, we can reduce the mesh size at critical areas. So that will definitely increase the confidence level of the results, because no need for the time consuming manual meshing is there. It eliminates mesh related uncertainty with automatic mesh adjustments, and at the same time it gives balance between the accuracy and the cost as well. Concurrent engineering of assembly models. We can do the analysis for different types, like 1D, 2D and 3D elements can be combined, that is hybrid assemblies. For the model, we can have solid mesh for the few of the parts. For few of the parts, there can be 2D meshing, and there can be some wireframe, that is 1D elements also can be there. So this is called as the hybrid assemblies. This allows, CATIA Analysis also allows several designers to work together using assembly of analysis. Different people can do the analysis of their parts, and that can be combined to get the assembly of analysis. So that will be a concurrent or simultaneous engineering, which reduces time very drastically. Along with that, realistic and accurate simulation based on connections to surrounding parts. There can be bolts elements, contacts, welds, so those are also possible. Design optimization. This optimizes structures to meet targets. This has product engineering optimizer. This can be used to arrive at the best design in very less time. So this drives the parameters to reach defined objectives. This minimizes the mass, maximizes the stiffness, stress and displacement requirements. This particular slide will help us to understand the CATIA V5 analysis portfolio. What are the different licenses that are required? So this it is having GPS, that is Generative Part Structural Analysis. So this particular license, this capability will help us to analyze the parts, the analysis of parts, individual parts. With the help of GPS, we can do the static analysis. We also can do the frequency analysis to find out the natural frequencies of the parts, free frequencies. Along with GPS, the CATIA also has the assembly analysis, generative assembly structural analysis. This is a generative stress model analysis for hybrid assemblies as well. So this gas GAS will help us to analyze the assemblies which are created in the CATIA, and they can be analyzed. Along with the GPS and GAS, EST, this CATIA analysis has Elfini solver. So multiple load cases can be analyzed with the help of this EST. So different solution cases which has advanced options for pre and post processing and solving it. If anybody is having any queries, you can type in the chat window, you can ask. Along with this, the CATIA analysis will have FMD and FMS. FMD will give us advanced meshing options for solids. At the same time, this FMS will give us advanced meshing options for the surfaces. So this mesh refinements can be done with the help of FMD for solids and FMS for mesh. The GDY capability will give us generative structural dynamics response analysis. So this is also possible with the help of GDY. Now, how exactly it is done? With the help of some examples, we'll see it. Industry cases, as we have discussed initially as well. Different industry verticals, this analysis, CATIA analysis capabilities can be used, ranging from automotive, aerospace, consumer goods, and construction, etc. One of the strong and important feature of this is it is very user friendly. In the same environment of modeling, these capabilities are present. Analysis specifications are geometry based. We can do the changes in the geometry very easily, and simultaneously this will be updated in the solution, that is analysis solution. So here there is a one assembly which is the example for a life sciences industry, where one specific part is taken and it is to be analyzed. Now they are going to the generative part structural analysis. So here we have static analysis and frequency analysis that can be selected. The boundary conditions are applied. This will giving this as the solid part 3D meshing, and then they will be applying the load of 320 lb, that is the distributed force, and it is given for the solution. Here it is, distributed force is applied. Now it is given for solving. As we have discussed, this CATIA is having Elfini solver, which is solving. After solving, to understand the results, we have these tools. Here it is showing where the stresses are more. Wherever this red areas are there, it shows this the stresses are more at that particular location. Along with that, we can do the simulation, the analysis of the analysis, so that the user will able to understand how the part will behave under that loading with the help of animations. As we have discussed, this CATIA is having assembly analysis. So here the designer can focus on the geometry and automatically how it will be updated in the analysis. That we'll see. It will easily understand whether the design changes improve the performance, we can change the size of the parts, properly size and design, and materials where it is needed. So this is a typical assembly analysis. Now user is doing the analysis, and if the modifications are required, so they are going to the modeling workbench. Here the user is in the generative shape design workbench and doing the changes in the geometry based on the first iteration of the design. Some changes in the fillets are done, changing the dimensions. These are the critical areas where the stresses were more. Now this, after doing the modifications, we need to once again update the analysis, and at the same time it will do that and will give us the solution. After solution, will in within very less time the designer will be able to get the best design for that particular analysis. The power of parameters. As we know, this is having the parametric modeling. So the parametric models with different configurations of designs. It is having design tables with the different geometric parameters, materials, and maybe mesh parameters and different loads as well. With the help of this, we can easily compare the different components. We can have different configurations of a component and their analysis can be compared with the help of this. So here a typical model with different configurations. So design table. So the configuration is changed, the dimensions of the part are changed, and the analysis solution is also got updated along with that. Here these are different parameters which are available for that design table, and this will control the part, the model which we have. And for the different configurations, we can do the analysis and the results can be compared. This was a typical example for a consumer packaged goods. How to control the accuracy for the adaptive meshing. This particular characteristic will have no need for time consuming manual meshing. This eliminates mesh related uncertainty of this will also provide the balance between solution, accuracy and cost. So here for this particular specific case, you will see initially the mesh size is different at this particular cases. So we need to do the fine meshing capabilities, fine meshing. So with the help of this adaptivity, the mesh refinement is done. See, the mesh is refined, and this will definitely gives the good results for the design. We initially saw that This CATIA helps us to have hybrid assemblies, which has say 1D, 2D or 3D meshing at the same time. This is called the hybrid assemblies for solid, shell and wireframe geometries as well. This allows designers to work together using assembly of analysis. Different parts can be differently analyzed, and that individual analysis can be combined to get the assembly of analysis, along with different capabilities, that is virtual bolt tightening, different contact elements, welds, the structure parts which are created in structure. So that also can be very easily meshed inside this CATIA analysis. So this particular automotive industry example will give us this hybrid modeling. Few of the elements are 1D. See here, this is the surface 2D mesh. These parts are having solid meshes, solid geometry. There can be some weld elements, spot welds. These are mesh dependent spot welds. Same welding also present. So bolted joints with the geometry. Here virtual bolts also can be, virtual elements can be elements, bolted joints without geometry. So this complex analysis can be very easily performed with the help of CATIA analysis. If the model size increases, so the analysis of those models becomes very difficult. So large models assemblies, so that also can be very easily modeled and analyzed with the help of CATIA. Automatic mesh generation models built using the structural design workbench can be meshed in minutes. The structural elements can be meshed very easily and in less time. Also, thin wall elements, beam type elements which are used for structures, so they can be also meshed. So this particular example from shipbuilding industry. As for shipbuilding industry, the assemblies are very large. Thousands of parts are there. So these bulkheads and other things, then shell elements. Now, with the help of the capabilities of the CATIA analysis, see here, this particular complex assembly will be modeled to get the finite element model, and within very less time we'll get these results. And the finite element model, and this can be easily analyzed for the critical conditions. You can see the number of parts or elements is very high. So large assembly analysis are also available with CATIA. Design optimization with the help of product engineering optimizer, that is PO. This optimization of the design can be done to attain minimizing the mass, maximizing stiffness, stress, displacements, and the other requirements. See here, this is a typical aerospace industry example, which will give us the optimization, how that can be performed inside this. See, this is a typical element and the location where the stresses are high. Now with the help of this optimization window, you can change the parameters and will run this optimization. So this CATIA will calculate it and do the optimization, and accordingly you will get the results. You can see the graph between these different types of elements here, fillets. In this way, here the optimization is performed and the analysis is very easily done. We can create the templates with the help of knowledgeware. Different parameters can be created which will control the part. Along with that, quick rules and checks can be created and they can be connected with finite element. So this is a typical example, loading the template inside the CATIA. See here, this was having one product. With the help of links, now it is replaced with another template and the analysis is once again computed. We'll see the results. These are different case solutions available. So this is for particular this button parts. It is analyzed and now modifications are done with another template. By replacing the part, now once again analysis is performed. This is a typical example from the high-tech industry. One more stresses translation displacement for specific the part called button, which is it is showing it here. So inside the same environment, modeling environment, we are doing the analysis and different iterations can be done. The parameters can be very easily changed and based on changes in the dimensions and the parameters, very easily we can get the right solution within very small duration of time. Across the world, there are so many customers. They uses this CATIA analysis capabilities, GPS, GIS. Along with this, there are many Indian customers like JCI, Tech Mahindra, Foundation Breaks, Susan Cooper. There are many people, they are using this GPS and GIS, that is CATIA analysis. Beyond CATIA analysis, we have this Abaqus for CATIA. If we need the additional functionalities like nonlinear analysis, thermal analysis, impact analysis, advanced contact analysis. So Abaqus is the best solution from Dassault system which has these capabilities. And they can be used with the help of Abaqus solution. Beyond the CATIA analysis, CA partners, that is if the computational fluid dynamics capabilities, CFD, noise and vibration, multi-body dynamics, So this also can be done with the help of CAA. If you have questions, you can ask, and I can show you a very small analysis inside the CATIA, how it is performed, how the CATIA analysis is very user friendly. So see, we are in this CATIA window. This is a typical say bracket part which is model in CATIA. Now to this particular model, to material properties need to be applied. So for that, we'll apply the material to this part. Select the part body. Now we can go to analysis. So here we have the generative structural analysis. Inside the analysis and simulation, we have generative structural analysis. As soon as we click on it, so it will ask us for this new analysis case. We can do, as discussed, we can do the static analysis, frequency analysis to calculate the natural frequency, as well as free frequency analysis. So for this time, I want to have the static analysis. Say OK. Now what we have to do is we have to apply the boundary conditions with the help of this clamp. I am fixing it at this location, this particular bracket. If it is resting on flat face, here we can also apply this clamp, or we can also have this surface slider. Distributed force of say 500 Newton in that direction. If it is that direction, we are applying. As this is a solid part, 3D elements will be there. The element size, we can control it, along with that absolute sag, which will define the difference between the geometry and the finite element mesh. We can have say linear elements or parabolic elements, higher order elements. We'll ask for a solution. So it is solving. Now it is solved. To see the displacement, what are the displacements? Here it is showing graphically where the displacements are more. Along with that, we can see with the animation. For complex parts, it always helps us to understand what are the implications of deflection at particular location. So this was showing the displacement. We can also ask for stresses if we want to see. Displacement as well as the stresses at the same time, that is also possible. The stresses graph and displacement graph simultaneously we can see. So one of the important thing as far as this CATIA analysis is concerned, it is very user friendly. And in the same environment, we can do the analysis. If any doubt, you please ask.
Thank you, Swapnil. We have some of the queries from the attendees. We just go for the queries one by one.
Okay.
Mr. Jagabandhu Mohapatra had asked that whether this option is available from in CATIA V6.
Yes, in CATIA V6 also it is available, but it will have different diagram. Like here, this for this we were concentrated on CATIA V5 capabilities. So GPA, GAS, these are the trigram for CATIA V5. So similarly, it will be available for the V6 as well, but it will have the different trigram.
Dear attendees, I am unmuting you. You can ask your queries. And the next one is Mr. Ashish. Mr. Ashish Mahadikar, he is asking about the GDY. Can you ask your query? Hello, Mr. Ashish. Hello, Akshay.
So this GDY
yes.
will help us for inside the CATIA environment. It is used for generative structural dynamic response analysis. So this will require this GDY capabilities.
Hello, Akshay.
Hello, yes.
Yeah, if you have the query, you can ask here. Hello. Hello.
Hello, can you hear me?
Yeah, is this Mr. Vibhu Gupta?
Yes.
Yeah, you can ask your query.
Okay, so our question is how we can use this for noise and vibration analysis.
For this noise and vibration analysis, sir, as we discussed, we have the solution for this in the SIMULIA background. 1 minute. The SIMULIA Abaqus solution. Abaqus will help us to do those things.
Okay, so can we have some? Yeah. This is Abaqus finite element analysis or this advanced simulation, first one?
This is Abaqus finite element analysis.
Okay, so
Abaqus will give the better results for this particular case because this it is totally specific to the higher end analysis, Abaqus capabilities, which is also very good for non-linear analysis as well.
so if we want to know more about this application, how we can get?
Yes.
Mr. Vibhu, for the more detailed application, as of now, as the time is permitted, we can give you a personal one-to-one demonstration about the solution.
That is why I'm
Ajay, we can note down their contacts and we can get us this SIMULIA experts we have, Abaqus experts, and sir, they can definitely resolve your queries.
okay, sure. No problem.
Thank you.
You please share your contact details to Mr. Ajay. We'll definitely get back to you.
Okay, thank you.
Thank you.
Okay.
Swapnil, we have a query from Mr. Ashish Mandikar. He is asking about whether the results on for the frequency response function in CATIA workbench.
I mean, about this natural frequencies.
Yeah, Ashish, you can ask your query. Yeah, I have unmuted you. Hello, Ashish. His query is, we are unable to contact you. Can you please elaborate whether we can get the results for frequency response function in CATIA workbench?
With the help of this CATIA workbench, we can find out the natural frequencies and free frequencies as well. So it gives good results for these cases. People use it for their design these capabilities.
One more query from Mr. Akshay Jagtap, and he's asking that whether what is the SAG and how to decide its value.
Sorry?
What is the SAG and how to decide its value?
Okay, SAG.
Yeah.
SAG is nothing but when we are modeling up this finite element, so always there will be difference between the finite element model and actual model. So if say 1D elements are there and we are modeling it, 3D elements are there, and with the single, or that is, we are not using higher order elements like when we were doing this thing. See here, linear elements and parabolic elements. So the difference between the finite element model and the geometry, that is nothing but the tolerance, we can say. So this we can reduce, but as if we reduce this thing, so it will also increase the time to solve our model. If we reduce the size of the element as well, the number of elements are going to increase, so time to solve also will increase. So we have to do the optimization, the best thing whatever we need to do. As per, we can check out the errors, and based on that we can go on refining the mesh, reducing the sag, because after some time we will not get the much improvements in the solution. So at that time we can stop this thing.
Swapnil, the next query is from Mr. Epan John, and he's asking, can we do the nonlinear analysis in CATIA V5 itself, or we need to use Abaqus only?
Abaqus, we need to use the Abaqus for it.
Okay. Next query is from Mr. Sheshu Kumar. He's asking, what are the basic qualifications for the designer to use CATIA analysis?
Basic qualification?
Yeah.
Means say education.
What is the
basic knowledge of
basic skill set for the designer to use this option?
See, they should know the finite element method. See, this is required for any of the people who are using analysis solutions, so because what actually the software is doing behind on background, that if the user is knowing, so it will definitely help the designer to adopt the right process, right say element sizes and other things. So basic finite element method, that basics need to be very clear. So that definitely will help.
Okay, thank you, Swapnil. Thank you for everyone. Hope you had the good session and the value adding session today. And if you have any more queries, please mail us to the given mail ID as marketing@edstechnologies.com, or else Mr. Swapnil.pna@edstechnologies.com. We will resolve your queries through mail or through the individual personal demonstration. Thanks for your time.
Thank you all. Thanks for your patient listening and your interest.
Thank